All right, I'm kind of faking you out a little bit because we are going to talk about 4.6, which is complex numbers. Any math class above Algebra 2, that's what they call them, complex numbers. Actually, in Algebra 2, they call them imaginary numbers. Okay? Now, this was my fake out, all right? I'm going to talk about something else first. But I wanted that on there for the video so that I would know. I gotta find my notes. So I'm going to, before we talk about that, I want to talk about 4.5 and some issues that I saw on your worksheet. Okay? So I've already graded your 4.5 worksheet. So I want to talk about some things that I saw that I'd probably put them somewhere just so you can make sure. Do you still have a worksheet that has problems from 4.5 on it?
Yes.
Yes, you do. That review is over 4.3 through 4.6. So they're still on there. So you might want to make sure that you didn't make any of these problems. So here was one of the things that I saw. This might be the answer that you got for the problem. Y'all, I'll take this answer. I don't have a problem with this answer. I will say this, that if you were to look up the answer in the back of a textbook, or if you were taking a standardized test like the SAT or the ACT test, this would not be one of your answer choices. They would not leave that negative in that bottom. All right? So here's some of the stuff that I saw. Sometimes kids did this. They just pulled that negative up to the top. Can you do that?
No.
No, you can't, because there's more than one term up there. All right? So you can't just pull the negative up to the top. If I pull it up to the top, what do I have to do with it? Yeah, you have to distribute it. You have to push it all the way through the top. So while this 4 becomes a negative 4, what happens to the negative 3 square root of 6? It becomes a positive. These two are equal. If you just push that negative up there above that line and put it down there, I said, if you had this and then you wrote that without changing that sign, I said -2. No, you cannot do that. That is not legal. Okay? Here's another way you can do it. This is a very dangerous way, so it's probably not the way I would choose for you to do it, but you can put that negative sign in the middle. But if you push that up above that line, I'm going to say -2, minus half credit, okay? So it has to be smack dab in the middle. You cannot just kind of halfway do it and be messy about it, all right? Now, one of the other kids said, Miss Davis, can I do it like this? Can I push the negative up to the top, but then put that in parentheses? Yes or no? Yes. I don't like this because this just says that you were either too lazy to pull that negative through those parentheses or you didn't know how, okay? So I don't like this way. Either one of these are okay with me. I don't have a problem with this. If you left it like this, I gave you credit for it. I don't really care. But I do want you to understand that on a standardized test or, pardon me, if you were looking in the back of a textbook, it would not have an answer that looked like this. Okay? Here's another issue. Let's pretend that our answer was the square root of 3 over 4. And I had kids that wrote this. Yeah, see, I don't really know where this radical, I don't know if you were sloppy and you just made it extend below the line, or is it really the square root of 3/4 and you just didn't bring it down all the way, okay? So I would take off for that right there. So you need to be very careful about that. Don't do that. Here's another place I saw it happen. If I had the square root of 36, then some people just do this. And I'm like, whoa, wait a minute. Is that 6 times the square root of 3, or is that the square root of 36. Do you see what I'm saying? Most of it's about being neat, okay? Most of it is about being neat. All right, so I got two more little issues that we had. Here's the first one. It looks something like this. X plus 4 quantity squared is equal to 18. So you got it down to this right here. Now what do I do to solve it? Yeah, square root both sides. So this square root takes care of that square. Okay, those are opposites of each other. So I'm left with x plus 4 is equal to, what is the first thing I should write down? Plus or minus. Y'all listen to me. If you would do what I tell you to do, you wouldn't make these crazy mistakes. All right? So 18, y'all, you can't leave that 18 underneath that radical. He's not simplified. That's why we learned how to simplify radicals. What's a perfect square that's a factor of 18? 9. So this is 9 times 2. What is the square root of 9?
3.
So I got 3 square root of 2. Do you agree? Okay. So now, have I solved for x? No. I need to subtract this 4. Now, where does that 4 go? I made a big deal and told you where to put the 4. He goes in the front.
Oh.
Okay? And it ends up being negative 4 plus or minus 3 square root of 2. And some of y'all would like put it in the back, and you made it look like this. I don't like that. It doesn't look good. Okay? So I don't want you to do that. I made a big deal out of that. Don't do it. Okay? And then some of y'all just got so confused that you like did this, and then you said, oh wait, it's plus or minus. So then you just stuck your plus or minus wherever you wanted to. No, people, the plus or minus goes in front of whatever you took the square root of, not just pick whatever you want to. Okay? So I don't like that. That one's wrong, and this one's not written correctly. Okay? So I'm going to show you where it comes up again. You did that? Okay. If you wrote it like this, I did not count it wrong, okay? I just maybe circled it at some place and said, don't do that. It goes at the front, or circled it and put it at the front, wrote it like I wanted it. Okay, so now this is where the problem kind of morphed into something else, okay? So you ended up with something like this, all right? And then we did the same thing. We square rooted both sides. So you got x minus 1 is equal to. I took the square root, so that's where my plus or minus sign. What's the square root of 9? 3. So now I'm going to add 1 to both sides, okay? Here it goes in the front, guys. 1 plus or minus 3. And if you left it like this, I gave you half credit. Because I think that you should know what is 1 plus 3.
4.
What is 1 minus 3? Negative 2. So those are my answers. Okay? Now, here was a problem that we had. A lot of the times the kids did this. They said x minus 1 quantity squared equals 9 square root. X minus 1 equals 3. Add your 1. X is equal to 1 plus 3. And then x is equal to 4, and then they were like, oh wait, we're supposed to have a plus or minus. Oh, okay, plus or minus 4. No, you can't. Do you understand what I'm saying? The plus or minus goes where you took the square root. Here's where the plus or minus is. You can't just like get an answer and then stick a plus or minus on the end of it, or the front of it, okay? So those were the things that I saw on that worksheet that I did not like, okay? I'm going to give you back your worksheet tomorrow, so then you can make sure and look over it. If I get finished with 4.6 tomorrow, then we will test Thursday, Friday. If I don't get finished, then we will finish it up Thursday, and we will test Friday, Monday. And whatever day I test it, the first day, that's the day that that worksheet will be done. If you're procrastinating on that worksheet, then it's going to bite you, okay? Because that's a long worksheet. But you've had, I don't know how many days in class to work on it, right? You had like 2 days, Thursday and Friday, to work on it in class. I know that you didn't, I wasn't here to help you, but it was stuff that you all knew except for the last. All right, so here we go, complex numbers, imaginary numbers. So why do we have them? This is why, let me see if I can find my notes. I did them in a different order the second time, I liked it better. Okay. All right, so this is why we have complex numbers. There was a guy, a mathematician, he was trying to solve this equation right here. Okay, so tell me what to do.
Subtract 4.
Yeah, just subtract that little 4, right? And so you got x squared is equal to -4. This looks like a really easy problem, doesn't it? And then I take the square root of both sides. That goes, and x is equal to plus or minus. Whoa, what's the square root of -4? Yeah, what can you multiply by itself? Some kids are going to say -2, right? -2 times -2 is +4. All right, so here's where the problem came along. So, because a mathematician doesn't want to have a problem he can't solve, all right? So he discovered a whole set of numbers that would allow us to solve problems like this, okay? All right, so we're going to start off, we're going to make us a little chart. Okay, on the left-hand side of the chart, we're going to put what's not legal. These are things that you cannot have in your answer. These are ways that you cannot write your answers. Okay, on the right-hand side, we're going to put what is legal that it's equal to, what I can change it to. Okay, you with me? All right, so the first problem is this negative underneath the radical, right? If it were just the square root of 4, we'd say plus or minus 2. But this negative under the radical, he creates a whole different problem. So what I'm going to do is I'm just going to kind of take care of that negative all by himself, all right? So I'm going to tell you that the square root of -1 is I. It is a cursive I. You could say it stands for imaginary numbers, but it is a cursive I. It's not a print I. Okay? So the square root of -1 is I. Now, I want to know what, yes. So I want to know what I squared is. Now y'all think about this. What's the square root of 3 times the square root of 3? The what? What's the square root of 3 times the square root of 3? 3. What's the square root of 17 times the square root of 17? 17. What's the square root of 492 times the square root of 492? Okay. What's the square root of -1 times the square root of -1? -1. So I squared is -1. All it does is remove that radical. That squared removes that radical. Okay? Just like a square root removes that squared. Kind of opposites of each other. All right? So what about I cubed? Okay? What is I cubed? Well, could I say that I cubed is I squared times I? Is that true? Yeah, you got 2 here and 1 there, so that makes 3 of them. What is I squared? -1. So what's -1 times I? -1I, or just -I, right? Are you with me? Kind of weird, but okay. So let's do I to the 4th. Do you agree that I to the 4th is going to be I squared times I squared?
Yeah.
All right, got 2 here and 2 here, so that's 4 of them. What is I squared?
1.
-1. What's -1 times -1? So I to the 4th is 1. Well, what about I to the 5th? Now watch what I'm going to do here. I to the 5th is I to the 4th times I. Do you agree? Okay, all I have to do is make however many this tells me to make. Okay, what is I to the 4th? Look at your chart. 1. What's 1 times I? I. 1 times I is I. All right, what about I to the 6th? Okay, well let's see. What am I going to do? I'm going to say I to the 4th times I to the 2nd. What's I to the 4th? 1 times what's I squared? What's 1 times negative 1? Negative 1.
This is weird.
What about I to the 7th? I to the 7th. Well, that's going to be I to the 4th times I to the 3rd. So that's 1 times negative I. That's going to be negative I. Layden, what did you say? What did you, Andy, you said something? Andy said pattern. Is there a pattern? Should be, if it follows the pattern, Andy said there's a pattern. He said I, negative 1, negative I, 1. I, negative 1, negative I. If this is 1, then I'm thinking, yes, we got us a pattern. So I to the 8th. Well, what's that? I to the 4th times I to the 4th? That's 1. Is it a pattern? How many do I have to know? 4. That's what you gotta know. Okay? That's what you gotta know. So here's the deal, guys. If you're multiplying or doing whatever, and you get an I squared, you better substitute a negative 1 in for that I squared, because he's not legal. If you're multiplying and you get an I cubed, you can't use an I cubed. You gotta put a negative I in for him. I cubed is not legal. Okay, so these are the ones I need to know. Do I really need to know the left-hand side? No. Do you agree? Y'all, it just, I mean, this is I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. I to the 5th, I to the 6th, I to the 7th, and I to the 8th. Are you with me? So this is the only side that I have to know. Are you okay? Let me show you an easy way to remember it.
Yeah.
Okay, here it is. All right. So most of the time the kids are taking like 10 seconds before they get it. But this is the easy way to remember it. All right, watch up here. I won. Keep your negative stuff on the inside because nobody wants to see all that. All right, so here it is. I won. Keep your negative stuff on the inside. Keep it in between them. All right, it's not pretty. All right, so I squared, I to the 3rd, I to the 4th. All right, is everybody okay? Okay. So let's do this. Let's go down here and let me show you what this is used for. Okay? Let me go down here. I'm going to show you what it's used for. Let's talk about the square root of negative 9. The square root of negative 9. Okay? So, do you agree that that is the square root of 9 times the square root of negative 1? Is that true?
Yeah.
Okay. What is the square root of 9? 3. What's the square root of negative 1? I. So the square root of negative 9 is 3i.
Whoa. It's weird.
Are you with me?
Yes.
Okay, let's do another one. The square root of negative 25. What's it equal to? What? 5i.
Wait.
So it's just plus or minus 4.
5i.
I'm talking about that.
So it's just a regular square
What's the
root.
square root of 4?
2, my bad. 2i.
2i.
It's just
Exactly
regular
right.
square root.
Okay. Yes, that's exactly, put an I on. Okay, so here's what Matthew said, this one, he's thinking about this problem up here. So actually, the answer to this problem is plus or minus 2i. Okay? All right, let's try some more. Some of you are still like going, what? What is she talking about? The square root of negative 100, don't say the answer out loud. The square root of negative 100. What is it? 10i. People, listen to me. You take the square root and you pop an I on it. Okay? That's it. All right? That is it. That's all you have to do. Y'all listen to me. If you have a negative under the radical, you better have an I in your answer. It's not a real number. Okay? If you have a negative under the radical, you better have an I in your answer. Riley,
So it's always going to be like a perfect square?
No.
I'm going to do one of those. I'm going to get to it. Okay? So what about this one? The square root of negative 49. Don't say it out loud. Just write it down on your paper. The square root of negative 49. Tell me what you got.
7i.
7i, very good. What about this one? The square root of, oh, we're gonna see who knows them, negative 196. Don't say it, negative 196. Tell me what you got.
14i.
Very good, 14i. So, this is what Riley's asking about. The square root of negative 12.
Can we just forget about that?
The square root of negative 12. Now y'all listen to me. Is there a perfect square that's a factor of 12? 4, right? So put the negative on that perfect square. This is negative 4 times 3. What is the square root of negative 4?
Wait, slow down.
2i.
Oh.
And who stays underneath?
3.
All right, you want to try another
I
one?
hate it.
Do you have to know how to do radicals to be able to do this?
Yes.
Yes, you do, people. It's just more practice. Negative, the square root of negative 32. The square root of negative 32. You do it really quick.
Wait.
Okay, you got it? What's a perfect square that's a factor of 32? 16. So first of all, you probably thought 4, and then you're like, oh yeah, I gotta try 16. So put the negative on the perfect square. So negative 16 times 2. What's the square root of negative 16?
4i.
4i times the square root of 2. Okay? Now, there's one little thing that I need to warn you about. Okay? In the back of the book, this is not the way they're going to write the answer. Okay? In the back of the book, or on a standardized test, they're going to put it in what's called proper form. Okay? We're going to talk about that in just a second. But it's going to look like this. 2 times the square root of 3, I. Now, do you see why we don't write it this way? Because y'all are so sloppy that y'all would take that little line and throw him out there, and then this I would be underneath it, and I would mark it wrong. Okay? So this is the way that we write it, so that we don't have to be quite so precise.
What was it called? Proper form?
Do what?
It was called proper form?
I'm fixing to show you the proper form. It's called standard form.
Oh, okay, well,
Okay? So this is standard form for a complex number. Standard form is in the form of a plus bi. A plus bi. This a is my real part, and this bi is my imaginary part. Okay? Notice that the real part comes first and the imaginary part comes second. If this were my answer and they said write your answer in standard form, let's just pretend we had the plus. What would I write it as?
X plus G.
What's the real part? Does it have a real part?
No.
So what is it?
X equals 2.
No.
X
If you don't have any money in the bank, what you got in there?
X equals 0.
0.
Oh.
Okay? So in standard form, this would be 0 plus 2i. Alright? That's the way they would write it on a standardized test. If they said put your answer in standard form, 0 plus 2i. Yeah, there wouldn't be any eggs. Okay? It would just be the answer. Okay, so one last thing and then we'll stop. We want to write what's legal. What's legal in this classroom? What's legal for your answers? What will cost me points or everything in that one problem? So first of all radicals must be simplified.
That's a good
Okay, all radicals must be simplified. That means on that worksheet 4.5, I saw some kids left the square root of 12 under the radical. Like, come on, people, that's not simplified. No, wrong. Okay? Here's another one. No radical square.
In a fraction,
Where in the fraction?
on top, or bottom?
Bottom. No radicals in the denominator.
I thought you said no radicals in square. And I was like,
What?
No radicals in the denominator. If you have a radical in the denominator, you have to rationalize it. That means get rid of the radical in the denominator. Okay? Here's another one. No negatives under the radical.
Wait, so you're saying we're gonna have fractions in this?
No, I didn't say we wouldn't have fractions. I said you can't have a radical in the denominator. You know, we did one like this. Like if you had 2 over, you can't see that. If you had 2 over the square root of 3, that's my answer.
Oh, yeah.
That's the answer, but it's not in the proper form, right? It's not legal. Remember what you had to do? Multiply by the square root of 3, the top and the bottom. On the bottom, what's the square root of 3 times square root of 3? 3. On the top, what do you have? 2 square root of 3. This is the legal answer.
Well, I mean, in, like, imaginary numbers and stuff, are we gonna have fractions?
We're gonna talk about that. We haven't gotten to that yet. Okay? All right, here's the next one. I can only be
Imaginary.
to what power? Look at all those things over there that are legal.
Four.
First.
What? All of these on this side are legal. All of these are not legal. See that? Not legal? Legal. That's right. I can only be to the first power. Now y'all listen to me. I'm going to warn you. I wouldn't try to do my worksheet yet. We just barely stuck our toe in the water. Okay? There's going to be a lot of issues that are going to come up. So I would just wait on my worksheet. All right? And then we'll take care of it. We're going to stop now.